Good morning, everyone. My name is Graham Masson. I'm the sales manager based in the UK. We cover the North Sea and also African operations. Today I'm going to be speaking to you about some of the solutions that Interwell can provide to enhance the production of the current well stock. For those of you who don't know Interwell are a leading global technology company who pride themselves in being able to provide our operators with bespoke technology and engineering expertise to deliver solutions to our clients around the globe. So who are Interwell? Interwell are a Norwegian company. Our headquarters are in Stavanger in Norway. We also have a large R&D facility in Trondheim in the north of Norway. It's closely linked into the university, so we can rely on their bespoke engineering expertise to provide solutions to all our clients around the globe. We have over 400 employees globally in 18 locations. So we have offices in Perth in Australia, Houston. We have a number of offices in the Middle East, headquarters in Stavanger, as I said, in Norway. And where I'm based in Aberdeen, we have around 50 employees in Aberdeen who are covering, as well as operations in the North Sea, we're also covering operations throughout Africa. So far we've covered operations in 10 African countries to date, and at the moment we have operations ongoing in Angola, Nigeria and Congo. So these figures up on the screen, although specific to the UK continental shelf, what they're designed to do is to kind of highlight some of the challenges that we're seeing in regards to interventions in the industry. These kind of show the lack of interventions that have been carried out. As you can see, the figures up here, we have in the UK over 600 wells that are shut in. That's 30% of the existing well stock. And now these figures were taken from the UK Oil and Gas Authority report that was carried out last year, and they kind of highlight the lack of interventions that are being carried out. And although, as I said, specific to the UK, we do think, it is a global issue, the lack of interventions. But you can see the intervention rates are low, but where interventions are carried out, the figures there in 2017 show that 22 million barrels of oil were added by carrying out interventions, although 33 million are still not achieved as a result of well losses. So, it is a huge problem for the industry, and it's something that we believe we can provide solutions to enhance that production of your existing well stock. So why do we intervene? Well, basically we're trying to prevent the need to carry out a costly workover. By providing intervention solutions, we can reduce those costs, we can maximize the production of your existing well stock, therefore increasing the life of your well. And often when you're carrying out interventions, the costs of doing these interventions are quickly recovered as well. Interwell's business has really been based around barrier solutions. Now, we have a number of core barrier solutions that, if we're looking to enhance the production of your existing well, these can be used for water shutoff. So if you're wanting to kind of isolate your lower zone in an existing completion, these barrier solutions will provide you with potential ways of shutting off water. Now, with all our barrier solutions, we, as standard, test them to ISO 14310 V0, which means they're gas-type barriers, giving you that gas-type barrier in your well. We also provide the highest expansion bridge plugs on the market, meaning that we can pass through restrictions in your well that nobody else can. And these 4 products that we have here, we have an ME bridge plug. It's our workhorse plug. It's a 5K rated plug up to 150 degrees C. What stands us apart from those of our competition is that we can still provide smaller ODs, meaning that we can pass through restrictions that no one else can. For instance, if you look at an ME bridge plug, we have a 4.2 OD for 5.5 inch So, if you compare that with other products that are in the market, they normally come in around about 4.4, meaning if you've got maybe a 4.313 restriction in your well, it's quite easy for us to pass through it with our standard product. The HPHT plug, high pressure, high temperature plug, can achieve up to pressures of 12,500 psi differential and 220 degrees C. Not always used in high pressure, high temperature environments. The reason I say that is because, again, it has a smaller OD than our standard product. Again, if you look at a 5.5-inch completion, this is a 3.98 OD, so ideal if you want to pass through like a 4.125 nipple profile. The hex plug is our next plug in our core barrier solutions. It's the highest expansion bridge plug on the market. It ranges in sizes from 2 7/8 right up to 10 3/4. It's a good thing about the hex plug is that it can pass through your upper completion and isolate water in your liner. The expansion ratios we can achieve on the high expansion plug, if you're looking at 5.5, you've got a 2.7 OD for 5.5-inch, right up to sort of 9 5/8 where we can provide a 5.2 OD. So easy to pass through your upper completion and set in your liner below. Now there are limitations with high expansion bridge plug because we're going to such high expansion ratios. There are limitations in terms of the pressure and temperature that it can provide. So the hex plug is rated to 4,000 psi differential and 110 degrees C. So we understand those limitations, and what we have actually developed now is the T-hex, or the temperature hex. So now with the temperature hex, we can achieve higher pressures and higher temperatures, a 5K differential plug, and 160 degrees C rated. When we do go to those ratios, so we do have to slightly compromise on the OD. I think with the hex plug, if you look at the 7-inch version of the hex plug, we can give you a 3.5 OD. With the T-hex, you're looking at 4-inch, just to kind of achieve those kind of higher pressure, higher temperature ratios. So that's our kind of core barrier solutions, but what it is, it's quite easy. We can understand for enhancing production, straddle solutions is something that we kind of often use. And all that technology, the ME, HPHT, hex, and T-hex, it's easily to adapt into these straddle solutions. Now, what's the advantage of straddles? It can kind of provide you with a cost-effective alternative to carrying out an expensive workover. As I said earlier, we're looking to try and increase the production from your existing well stock, and by utilising our technology, we can pass through restrictions in the well that some of the competition can't. All these design concepts that can be deployed, slickline, E-line, coil tubing, or drill pipe. We can do single run or multi-run options. We've done straddles up to lengths of 500 feet by just stacking these straddles up with a unique stinger and latch system, and they've got an extensive run history as well. So as you can see here, what we're trying to do is trying to explore the possibilities of increasing production. And that can be done through well integrity. So if you've got a failed safety valve, PBR, just a standard leak in your tubing, we can straddle it off. We can enhance production by inserting gas lift into your well, or shutting off unwanted produced fluid by creating an AICD. We can shut off water through plug or straddle isolation, and also manage sand by retrofitting sand screens in your well. The medium expansion straddle is based around our ME technology used in our bridge plugs. It's available in 3.5 right up to 7.5-inch versions. But what I will say about the 5.5 and 7-inch applications, we can actually run a hex plug through it, meaning that we can pass through there and isolate the zones below after the straddle's been installed. I'll let you see an example of this. With an application in the UK where the client wanted to isolate an upper zone in their existing completion, the upper zone producing too much water, but the stipulation was from the client that they wanted the ability in later life to be able to run a hex plug through the straddle and potentially isolate a lower zone. So what we did, we set a 5.5-inch straddle isolating that upper zone. The upper interval was isolated and the well continued to produce for a number of years. Then at that point there was a requirement to run the hex. hex plug to isolate the lower zone. Now the ME straddle has a 2.9 2.9 ID through the middle of the straddle. So we were able to run a 2.8 hex through the straddle, therefore isolating that lower zone and still being able to produce from the middle zone. The next straddle in our suite is based on the high pressure, high temperature technology. Can achieve 5,000 differential pressure and 150 degrees C. Now that's really the straddle that most of our run history has been based around. But as I said, we're kind of producing these newer solutions, the hex solution, the ME solution. But the high expansion technology is something that we've seen a huge uptake on over the last couple of years. Being able to isolate lower zones where we have to pass through the restrictions in your upper well is a key challenge for operators. But you can see from the table up there, we've produced high expansion straddle solutions from 4.5 inch right up to 7 inch in both hex and T-hex solutions. Can you get an idea of the kind of ODs that we are able to achieve? We've done a 2.67 OD for 4.5 inch. 3.63 is our hex straddle in 7 inch. So, we can pass through, if you're looking at that 3.63, we can pass through restrictions in your well and then set in your 7 inch liner and isolate water producing or sand producing zones in your lower liner. Now, some of the, as I said earlier, the straddle can be set as just a means to isolate a leak. It can be just a means to isolate a water-producing zone. But with all our straddles, we can actually integrate third-party equipment or our own equipment. For instance, with the PBR straddle, what we can do if there's a requirement if there is extreme expansion or tubing movement, we can install a PBR in between our two modules. And basically, if you've got maybe a leak in expansion joint, we can install the PBR in between our two modules. And in addition to that, what we can also do is we did a job recently in the UK where we can have it set in different sizes of tubing. So we had a lower module that was 7 inch and an upper module that was 5.5 inch, and we had the expansion joint fitted in between it. Another solution that we can provide is if you have safety valve issues, if you still have control line integrity, but you have a failed safety valve, what we can do is we can use that existing control line, straddle your safety valve, and then what we can do is use the control line pressure to operate a third-party safety valve that's located at the bottom of our straddle system. We also can work in collaboration with a number of third parties. Now, we have a number of partners that we work with. First one being Tendeca. This allows us to basically, you take your straddle solution, can be single run, can be multi-run. If you've got a well where you want to basically shut off unwanted produced fluids, you can fit an AICD or an autonomous inflow control device. Now, what that allows you to do is it's a levitating disc that allows you to shut off these unwanted produced fluids. We work with 3M. 3M provide ceramic sand screens. The ceramic sand screens that are 20 times harder than normal sand screens. And by fitting these between your modules, you can isolate unwanted sand. We have also worked in partnership with other sand screen providers. And in fact, I think our longest sand screen straddle that we did was just under 500 feet. So it's you can see the capabilities, of having to be able to shut off these high producing sand intervals. Like I said, there's no real limitations on how high or how long a straddle system we can install in the well. One of our most successful collaborations has been working with PTC to provide retrofit gas lift. Now that retrofit gas lift can be a means to either deepen existing gas lift, it can be a means to put gas lift into an existing well that doesn't have, or just extend the point of gas lift in the well. I'll kind of round up my presentation by kind of giving you a little overview on a case study that we did in the UK. This was a well that was kind of completed in 2016. And due to the completion design, the lower two, there was three mandrels in the system, 3 side pocket mandrels, but due to the completion design, the lower two were deemed to be too deep for well conditions. So historically, they were only lifting the well through the upper mandrel. And that was fine, you know. There we go. Until we had a failure in that top valve. So when that top valve failed, they made a number of attempts to try and recover the valve. Unfortunately, all unsuccessful. So the operator came to us and asked us to provide them with a solution. So what we did is we, first of all, identified a depth between the upper and the middle mandrel. Tube and punch was carried out. Once the tube and punch was carried out, we run in with a 5.5 inch ME module, APS module. We set it below the tube and punch. So that was running on E-line, set below the tube and punch, prior to running in with the upper module. So you see the upper module using our unique latch and stinger system. That allows on your actual stinger, there's a protection sleeve, so it avoids any damage to the seal as it goes into the female receptacle. So then protecting it as you're running in hole, making sure your seals aren't damaged. Once the straddle's installed, you're creating a straddle across that tube and punch. And what that allows you to do is then inject gas down your annulus, in through the kind of the blue area, kind of located above that or below that upper module, allows you then to inject gas in through your annulus and then lift your well through the new gas lift. As I said earlier, though, there was issues on this well with the upper mandrel. The upper mandrel, we weren't able to recover the valve. So the client wanted to actually isolate that valve as well as increase the gas through in the existing well also. So what we did first of all, we punched the tubing above that mandrel where we couldn't recover the valve from, prior to running in with a, prior to running into with a one-run dual module solution, so basically isolating the existing side pocket mandrel. So basically it's just same as a one-run straddle solution, isolating that side pocket mandrel where we couldn't recover the valve from. The only difference between this and a standard one-run solution is it had a female receptacle at the top, and the reason for that being, like we did with the first straddle, it allows you to run in, stab into the female part then with your stinger system, then you can then inject gas through your annulus and in through your retrofitted gas lift system. And just to kind of round up the case study, here's some of the facts. This was a well that was unable to flow prior intervention. The average oil rate was 165 barrels a day post-startup, and meaning the intervention costs for doing this were recovered within 6 to 8 days. And this well is still producing 6 years after the intervention, is still the best producer in that field, so much so that the client has come back to us, and we're going back in July to carry out another intervention on one of their other wells due to the success of this. And we have now installed 25 of these gas lift systems around the globe. We have a number of interventions with the gas lift system being planned in Angola for late summer. We're also speaking to some clients in Nigeria also about this gas lift system. So there's a huge potential here, and it kind of highlights the kind of need to move away from your expensive workover and potentially look at intervention solutions that can kind of reduce your cost and kind of maximize your production.